Hello, everyone. Welcome back to the online open lecture. Today it's the seventh one. Thanks everyone who decided to join. And today we're going to cover quite a trendy topic, which refers to machine learning in MarTech. My name, as usual, is Maggie, and you can check out all previous open lectures in the YouTube playlist. And yeah, I think that we need to dive deeper into more theoretical parts of machine learning in MarTech. We covered machine learning when we talked about AI in MarTech, and also prior when we talked about chatbots in MarTech. So you can check out these online open lectures if you're interested to see, additional information in this regard. Also, QR codes here show different other possibilities for you to improve your knowledge in marketing and English for marketers. And if you're interested in that, please also check these initiatives out. Here's the slide about myself every time I show it to you, so I'm not going to go through it once again. You can just pause the video after you receive it in recording and read through something that I decided to bring out here as the introduction slide. So without further ado, let's just move on to the topic at hand. Machine learning. Machine learning, I presume that you've heard about machine learning, about deep learning, neural networks. But today we're going to talk particularly about machine learning, which is a big part of artificial intelligence. According to the definition of IBM, machine learning is a branch of artificial intelligence and computer science that focuses on using data and algorithms to enable AI to imitate the way that humans learn, gradually improving its accuracy. So generally, at first, it's about understanding how humans actually think in order to imitate it further, and to know how to store the data, which further will influence the decision making of the algorithms for them to be more precise and much better based on the data and feedback it receives throughout this educational process, learning process as it is. And we can see machine learning in plenty of examples. We're going to take a look at them later. But nevertheless, it's important to remember that machine learning, as any type of learning, whether it be when you learn any language or learn any topic, or if you learn how to drive the car, you have a set of processes or stages, to be more correct. So we have a decision process. So basically, how it is decided what to do, what to use, and which tools are needed to actually come to the particular decision to the task which is given. Then we have an error function that estimates the possibilities of making the decision based on the machine learning, like classification or regression, make it as correct as possible and to estimate the level of correctness of this decision. And this is actually what helps the algorithm and also the engineer, the person that writes the machine learning algorithm to understand what's going on within it and how to modify different aspects of it. And a model optimization process, which is based on feedback. So it can either self-regulate in some instances, or it can be regulated under the supervision of the data scientist, of engineer, or analytical profession representative if they do also this part of analytics. So when we talk about, I didn't mention in the beginning the deep learning and artificial neural networks for nothing, because these are very important topics that come hand in hand with machine learning. And the differences between them is that with machine learning, it is a little bit more clear what does the algorithm do. So you can structure it in different ways through different methods. Whereas when we talk about deep learning, artificial neural networks, these are about the fact that you give the algorithm a particular network input, then it goes within hidden layers. So, for example, here in this visualization, there is just one hidden layer, but sometimes there are tens at least of hidden layers. So information goes back and forth, and then there is an output. Indeed, it would be otherwise for me to just dive deeper in this part in the open lecture about machine learning. It's just for you to get an overview what it's all about. But nevertheless, this is the algorithm that gives you just the input and gives you an output. And based on the output, it goes back through the backpropagation to redefine internal decision making or weights of decision making results for it to actually follow through the different output, which as a result should show better output based on this optimization process. So this is about artificial intelligence. It is currently more it currently looks much more like human decision making because we have the black box in our heads. So, for example, an input and output for a different person goes differently because we have different life experiences, we have different cultural backgrounds, we have different thoughts, and all of that forms the black box of our thinking. So, one input for one person would be different output in the form of different output than for another one. Hence, this is something less controllable. But if we go back to the machine learning methods, as you can see here, we have at least four types. We have supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement machine learning. Currently, you may not really see any e-commercial platform or streaming service that doesn't really utilize any type of at least machine learning algorithm. I'm not talking about deep learning because it's sometimes irrelevant, but with machine learning, a lot of aspects of that is there. And now with the development of the speed, the need to make the decision making of showing or offering something to the customer quicker, the supervision from the side of the engineer or data scientist takes a bit more time than, for example, unsupervised approach and a reinforcement approach or semi-supervised. So these are also something, these approaches need to be defined particularly for your case, but it's important for you to know what it's all about. And if you want to read deeper, you can leave me a comment and I will make a closer overview of that. But you can also check out the website, which is referred here as a source from IBM to take a look at the theoretical foundation for these machine learning methods. When we talk about the benefits and drawbacks as any technology or anything in our lives, machine learning algorithms have their benefits and drawbacks. You can't really run away from that. So in terms of benefits, there is the fact that decision trees are easier to validate and audit than a neural network. So as I showed you earlier, the image of the artificial neural network, it is more like not so linear, but input, and when it goes through some internal weights allocation, and then it goes out as an output, and it also can use the backpropagation to take this output, go back and readjust the weights, and then try to optimize its decision making. Whereas machine learning algorithm usually works as decision trees. So you have some sort of a predicament and you have different ways for the algorithm to follow it through decisions. And it also looks like the tree branches. That's why it's decision tree. And hence, it is possible to optimize what you do based and control the decisions which your algorithm does. Usually, decisions that your algorithm makes. Usually, it is much more the feature of the supervised machine learning. Second benefit, machine learning can identify patterns and trends in massive volumes of data that humans might not spot at all. Indeed, when there is a rule and the data is given to the algorithm, it works quicker than the human that's going to count each line, forget about something over the coffee break and come back and not really spot a very interesting pattern. Technology does it quicker, but if it's programmed correctly. Machine learning analysis requires little human intervention. Feed in the dataset of interest and let the machine learning system assemble and refine its own algorithm. So, as I showed you earlier, the error functions and the optimization of the model that usually, even with intervention from the data scientist as a human, it still does plenty of its own internal work individually, let's call it that way, internally. Algorithms continually improve with more data input over time. So again, we go back to the process with optimization and learning about errors. Machine learning algorithm actually learns as human based on more and more input, more and more data, which it can actually use for the pattern recognition. Customers and users can enjoy a more personalized experience as the model learns more with every experience with that person. So, as in any type of communication, when you first see a stranger, you don't really know how to approach them. However, after several instances of communication, you then realize who you are talking with and what are the interests or some sort of approaches towards the behavior, like what they like or dislike, and you can learn and communicate better and more personalized way. And the same goes with the machine learning. The same goes with machine learning. The better system knows you as a customer, so you're logged in. There is your ID at the site, and what you scroll, what you click on, what you buy, what you wish to buy, all of that gives you the recommendations and personalized offers, and these are the prominent example of machine learning algorithms. However, there are certainly a set of drawbacks. Decision trees can be more unstable than other decision predictors, so it's not always possible to predict properly what to put in the decision tree, hence the problem. Machine learning requires large training data set that are accurate and unbiased. So there is this concept of garbage in, garbage out. So indeed, if you feed wrong data, which is, based on different indicators, which is purchased and you don't really know where it comes from, how clean it is, it gives you the algorithmical results based on what it knows. So it's really important to take a closer look at the data that you use to teach the machine learning algorithm for you not to get unclear at the very least and wrong at the very worst situation of the data, not to irritate the customers with wrong recommendations and personalized offerings. Gathering sufficient data and having a system robust enough to run might also be drain on resources. Indeed, if you can allocate the finances for this technology, you can benefit from it. However, sometimes it's better to use existing systems for you to use it for marketing decision making, like marketing analytics platforms within the social networks, or for example Google and all that kind of places. If you are not sure that you really need to purchase or establish any type of machine learning algorithm within your business. Machine learning can also be prone to error depending on the input. With too small of a sample, the system could produce a perfectly logical algorithm that is completely wrong or misleading. Again, the question goes back to the dataset. It has to be prominent in terms of its clarity, as I mentioned, and how much of information is there, how it is possible to make any sort of a decision based on the information that's contained in the dataset. To avoid wasting budget or displeasing customers, organizations should act on the answers only when there is high confidence in the output. So, as I mentioned, it's better not to irritate the customer with wrong recommendations unless you're sure that you have enough data and what you do is clear. And also, if you offer the possibility to give back the feedback on the decisions or offerings that you gave the customer for you to know if there is dissatisfaction from the customer perspective. So this is also something that leads to this work which goes outside the scope of machine learning and machine learning algorithms. And let's take a look at several examples of machine learning used in MarTech or marketing. As in general, first is speech recognition. So automatic speech recognition, computer speech recognition, or speech to text is the capability which uses natural language processing, NLP, to translate human speech into a written format. There's there are three prominent examples which I use also when I talk about this in my prior lectures. We have Siri, we have Google Assistant, and Amazon Alexa. Of course, there are many other voice assistants like local ones, or when you call to the bank and the bank assistant talks to you. So speech recognition is also something that's based on the determination of the parts of the word and how you can actually put them into text to further work through them. If you're interested in that, I recommend you to check out the previous lecture on MarTech and chatbots, because there I cover very interesting topics in that regards. The use of the customers for this customer service. For the prominent example is chatbots. So there are different types of chatbots, and if we talk not about the simplest ones, others are functioned by AI and hence use machine learning. So online chatbots are replacing human agents. Human agents are basically those people who work in a support department. So online chatbots are replacing human agents along the customer journey. Chatbots answer frequently asked questions about topics such as shipping or provide personalized advice, cross-selling platforms, products, or suggesting sizes for users. So generally, this is also about communication and also about the recommendations, as I mentioned earlier, because when you talk to the technology, it helps you to make decision. Computer vision. It's also quite prominent in the social networks when brands can see what their product, how the product images are used, and what are the conversations about it. If even if there is no tag or there is no mention of the brand, nevertheless, through the image, sometimes it's possible to understand whether it's something relates to you or not. And also, this is about the recognition of faces and social networks and all that. Recommendations engines. So, for example, if you go to Amazon.com, you right away get to this, the huge variety of recommendations there. So, according to definition by IBM, using past consumption behavioral data, AI algorithms can help to discover data trends that can be used to develop more efficient cross-selling strategies. Recommendation engines are used by online retailers to make relevant product recommendations to customers during the checkout process. So generally, they act as the online sales representative. They learn about you, and then they try through different formats, through different framings, they try to sell you something or help you to benefit from substitute products or some complementary products. For example, here is the screenshot from myamazon.com. So I was searching for the particular products in terms of cities, and here are the certain selection that Amazon.com decided that I'd like. And Absolutely not mistaken. And marketing analytics, as I mentioned earlier, the possibility to actually engage with the data and make decision making. Yeah, and how the decision making based on the quick analysis and proper information is very important. So customer centric focus, building stronger relationship, optimization of the customer acquisition and retention, and dynamic and relevant marketing outputs meeting evolving customer expectations. So this is about speed, this is about proper data, and this is about the realization of this customer specific approach that we have currently in marketing, the top personalization and communication in product offerings and all that. This is the prominent trend in marketing nowadays, and we cannot really get away from that. So that's that. Thank you very much for being here with me. Here you can see on the slide the sources. And yet again, you can see the QR codes to my website with all the events I offer you and different guides and all of that for you to go through, and also free exercises if you want to improve more marketing specific English. Then I have open lectures online and offline for you to see the dates and register to receive the links. MarTalks, this is online speaking club where I invite you to spend 1 hour practicing your conversations within marketing topic. And the MarTech guide, this is the document I created based on 12 years of my experience of communication with businesses and also in academic settings. So I really hope that it's something that will help you to understand where to learn, what to learn, how to learn. This is for the beginners or for those who are a bit confused in what to do in the marketing field, where to learn and how to actually make the decision making based on your career. So thanks a lot once again. I was Maggie, and I'm really looking forward to welcome you to the next online open lecture and other events. So thank you very much. Good luck. Dag Hondis.